Hi, I'm Martin Sweatman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. Now, so far we've covered the published research from the original Firestone et al. Paper in 2007 through to the middle of 2014 in the last video. And in this video I'm going to focus on one paper from 2014, which is a review paper by Holliday et al. Now, it's an important paper in the story that deserves some attention. Now, remember where we got to last time. Geochemical evidence for the Younger Dryas impact around 12,800 years ago has been found across the North American continent and into Western Europe and into the Near East by the Comet Research Group, and specifically nano diamonds, iridium-rich magnetic grains, and impact-generated spherules at the base of the Younger Dryas black mat have been found, and each signal has been confirmed by several independent research groups. Crucially, a platinum spike has been found in the Greenland ice that dates to within a few years of the onset of the Younger Dryas cooling. And probably the same platinum signal has also been found in Russian lake sediments. More nanodiamonds and evidence of wildfires at around the same time horizon have also been found in the Greenland ice, although these results have not yet been reproduced by other groups. Now, it's important to note that only about 7 or 8 of the black mat sites can be accurately and precisely dated to the beginning of the Younger Dryas period. Most of the other sites either don't have such precise age depth models or don't have them at all. Nevertheless, these 7 or 8 sites span 3 continents, from North America through to the Near East, suggesting that when accurate age depth models for the other 20 or so black mat sites are eventually created, they will likely agree with this date. So far everything is consistent with the Comet Research Group's claim of a single massive impact event caused by a swarm of comet debris spread out across perhaps one hemisphere of the Earth. Okay, so let's have a look at this review paper by Vance Holliday and his buddies. So you'll recognise some of the names here. They're well-known critics in this debate. Now look at the title, The Younger Dryas Impact Hypothesis, a Cosmic Catastrophe. Now that could be pretty funny, except it really isn't meant to be. It's meant to be intimidating. In fact, this is the academic equivalent of a great big stick being used to beat up anyone who is thinking that there might be something in this impact hypothesis. The aim of these authors is essentially to cow the academic community. If you publish an article in favour of the impact hypothesis, we'll throw a big stick at you too. So it's a long paper with lots of details. And let's begin with the first section in this paper, which concerns the impact model, and presumably it's written by Mark Boslow. Now, his basic argument here is that none of the impact models proposed by the Comet Research Group either fit the evidence or are at all likely. And we've heard him argue this before. And specifically, he claims, quite rightly, that if an impactor was larger than, say, 1 kilometre in diameter, then it should have left an impact crater, which should be obvious, and we haven't found one yet. Of course, this doesn't completely rule out a large impactor of this size, because any crater might be hidden on the seabed or under an ice sheet. And then he goes on, quite rightly again, to say that small impactors like the Tunguska impactor or smaller, which means about 100 meters or less in diameter, wouldn't have created all the impact proxies found, like the impact spherules and the nanodiamonds and so on, because they would likely explode as relatively weak air bursts high in the atmosphere. So that's all fine and correct so far. The problem with this discussion, though, is that he doesn't mention impactors of intermediate size, somewhere between 100 meters and 1 kilometer in size, which would be able to create all of the impact evidence found so far without leaving a massive and obvious crater. Now, this is a strange omission, and I don't know why he would do this, except, of course, because it would undermine his negative position. Now, I've had a few Twitter discussions with Mark in the past, and I kind of get the impression that he sees his role simply as criticising what's written by others. And it's quite true that these intermediate-sized comets, let's say between 100 metres and a kilometre in size, haven't specifically been mentioned by proponents of the impact theory. Their statements have been more vague than that. They haven't committed themselves to specific impactor sizes. But nevertheless, as a scientist, this is not good enough. If he knows of a scenario that might explain the evidence, even if it hasn't been mentioned specifically by other groups, he has a duty, as a scientist, to discuss that too. Now, on the issue of how likely such an event is in our recent history, only, say, 13,000 years ago, again, he's quite wrong. And he's correct to claim that a fragmented asteroid is unlikely to be involved, since these objects are extremely rare. And he's quite right to claim that we are unlikely to have collided with the fragments produced by disintegration of a small comet. But he completely ignores the possibility of a giant comet breaking up in the inner solar system in what he's written here. Now, we would be highly likely to have collided with fragments from the breakup of a giant comet. And indeed, according to this scenario, we should find many such collision events in our recent history, although perhaps none of the others might have been as large as the Younger Dryas impact event. Now, this giant comet scenario goes by the name of coherent catastrophism, which I discussed in video 7. And has been developed by British astronomers over the last few decades, namely Klube and Napier and their colleagues. In fact, events like the Younger Dryas impact are predicted by their model, by coherent catastrophism. The impact evidence found so far essentially can be taken as vindication for all their work. Now, Boslow knows of their work because he's been told specifically about it. In fact, Klube and Napier's work is mentioned in several of the Comet Research Group's papers, but most obviously, Bill Napier responded directly to Boslow's most recent critical comment. We saw this in video 7. And here is that paper. This is a response to Boslow's comment on an earlier paper by the Comet Research Group. So this is Napier telling Boslow directly about the giant comet scenario and providing reference papers to show it is very likely correct based on the latest astronomical observations. But Boslow doesn't refer to this discussion at all. He's completely blanked it in his text. Now, he even says that most comets do not break up in solar orbit. Now, as for many of his comments, this is misleading. I mean, he's correct for comets in the outer solar system and beyond, but in the context of coherent catastrophism, we are interested in comets orbiting within the inner solar system, like the Jupiter family comets. And these comets are known to fragment routinely. They fragment almost every orbit when they are closest to the Sun, and when they display some kind of breakup event. There are even papers that model the decay of comets in the inner solar system, like these papers, for instance. There's one here by De and colleagues, which discusses the physical decay of Jupiter family comets. There's another one here by Fernandez. That's the way the comet crumbles, splitting Jupiter family comets. So all of these papers discuss the routine fragmentation events of comets in the inner solar system. So this statement is essentially wrong, or at least irrelevant. And especially he shouldn't be making such strong statements as the combination of proposed size, configuration and trajectory of the impactor is exceedingly unlikely to have curved in the entire history of Earth, or statements like the probability of the fragmented comet impact event is about 1 in 10 to the 15. These are nonsense statements. They're patently wrong because they ignore the possibility of a giant comet fragmenting within the inner solar system. Essentially, throughout his discussion, Boslow uses the well-known straw man argument. He discusses situations or models that don't apply to the Younger Dryas impact or to coherent catastrophism, and then criticizes them. But he completely fails to address those situations or models that are relevant. So this whole section by Boslow is catastrophically flawed. Now, the next section in this paper concerns the dating of the Younger Dryas boundary layer. Now this is presumably written by Meltzer and Holliday, who co-authored the paper we looked at in the last video in this series. Now we binned that paper because it was so bad, and this section is based on that paper, so I don't think we need to go into this section in too much detail, but I will just point out their first line of evidence. Remember, Meltzer and Holliday were highly critical of the Comet Research Group for not having high resolution or high quality age depth models at all of their Younger Dryas boundary sites in their earlier paper, even though they failed to properly create their own. Now here, with this plot and the text that surrounds it, they are arguing that the Younger Dryas black mat has a wide range of ages at different sites according to the radiocarbon dating evidence. So in their view, it can't represent a single instant in time. But in fact, they're being hypocritical here. We've seen this data before, we've seen this plot before, in a paper by Holliday and Meltzer from 2010, and we reviewed it in video 2, so you might want to go back and review that video. So we know that there are real problems with this data. For a start, many of these data points are not published in peer-reviewed journals. They're just jotted down in archaeologist field notebooks, for example. The second problem is that we're not actually interested in the black mat specifically. We're interested in the boundary layer that contains the impact proxies, which may or may not correspond precisely with the base of the black mat, which is what this data is all about. So not only are Holliday and Meltzer using double standards in that this data is sometimes not even peer-reviewed, let alone doesn't have high quality age depth models associated with it. In any case, this data is relevant because we're not interested in the date of the black mat specifically, we're interested in the date of the Younger Dryas boundary layer that contains the geochemical proxies. The fact is, we would ideally like all of the Younger Dryas boundary sites to have fantastically high resolution and precise age depth models. The scientific reality is that this is just not possible. Like anything else, scientific research is limited by the resources available, basically research funding, which limits the amount and quality of data that can be obtained. And often what happens is, you'll take your samples, you'll take them back to the lab, which could be in a different country even, to analyze them. And then you realize that, probably we should have taken more samples or different samples, but you don't have the funds to do any more sampling. This is the reality of how research happens. So the point is, we saw from the paper by Van Hoesel et al. That there are 7 or 8, which is this plot here, we saw that there are 7 or 8 fairly well dated sites from across 3 continents. Would we like to have more sites like this? Yes, of course. Would we like these sites to have better age depth resolution? Yes, of course. But as things stand, we can only make a judgment on the data we have. And in my view, the 7 or 8 reasonably well dated sites which are in this plot are probably good enough. And certainly Meltzer and Holliday failed to show in their earlier paper that there were significant failings in these 7 or 8 good age depth models because their analysis was so dodgy. So this whole section by Holliday and Meltzer is catastrophically flawed. Now the next section concerns the impact indicators, the impact proxies, like platinum and so on, which we've covered in detail in these videos. So we know where we stand with these pretty much. So what do they have to say about them? Well, let's start with the most important indicator, the platinum signal in Greenland, which has probably also been found now in Russian lake sediments. So on this issue, they say that the platinum anomaly precedes an ammonium spike by 30 years. And therefore, the source of the platinum is unlikely to have triggered significant biomass burning. Now they're using this argument to suggest this impact was too small to lead to all the effects proposed, because the wildfires indicated by the ammonium spike were much later. But we know this is wrong. Remember from video 5 this plot that shows that the ammonium spike, which is this thick black line here, and the platinum signal up here perfectly coincide. So the problem can be traced, if you remember, to a simple typo in the 1993 paper by Majewski et al. Where this ammonium data first appears. So they've got this wrong as well. But then they go on to say that Petrovas et al. Accept arguments against the platinum depositing event being the cause of the Younger Dryas cooling. Now this is a very misleading statement. Petrovas et al. Say no such thing. This is the sentence they are referring to here. So this is Petrovas et al.'s response to Mark Boslow, who had criticised their paper concerning the discovery of the platinum spike in the Greenland ice. This is the sentence that they are referring to. Okay, so besides providing additional arguments against the platinum depositing event as the cause of the Younger Dryas cooling. Now that's a very different thing. What Petrovas et al. Here are doing is recognizing that Boslow provided arguments against the this platinum event causing the Younger Dryas cooling. But that's a very different thing to accepting those arguments, which is what is being implied. In fact, Petrovas et al. State their preferred view at the end of their response paper here. They say, therefore, the alternative assumed by us is either an abnormally high dust suspension or multiple injections of platinum-rich materials into the atmosphere. In either case, a global anomaly is expected. In other words, in either case, the Younger Dryas cooling is expected. So they are quite clearly stating that their preference is for, as they stated in their original paper, is that this platinum anomaly, this platinum signal, led to the Younger Dryas cooling. That is their preferred position. So when we go back to the cosmic catastrophe paper, when it says Petrovas et al. Accept arguments against the platinum depositing event being the cause of the Younger Dryas cooling, well, that is completely misrepresenting what Petrovas et al. Have said. In fact, to call this statement simply misleading is probably being too generous. Okay, maybe they did a better job with the nanodiamond evidence. Let's see. So that's this section here. So they focus on the issue of correctly identifying the precise crystalline structure of the nanodiamonds, which I'm not going to argue with. And it's true, there does seem to be a real scientific issue here as to which precise structure or which precise polymorph of the nanodiamonds is found. And I think that is an issue that needs to be resolved by the experts. But on the issue of the existence of nanodiamonds in general, they only have vague, unsupported statements like, for instance, the recent work of Bement et al. 2004 raises questions about the extraterrestrial origins of the nanodiamonds. So what they are referring to here is this earlier paper by Bement et al. What they're referring to is this double peak. There is a large peak at the base of the Younger Dryas black mat at Bull Creek, and then there is this modern large peak found near the surface of the sediments at Bull Creek. Now we know that nanodiamonds are formed only by intense explosions like cosmic impacts or perhaps volcanism. So what they are suggesting here when they question the extraterrestrial origins of the nanodiamonds is unclear, because no evidence of volcanism has been found at these particular layers in the sediment. Then again later in the text they say several questions remain regarding the nature and distribution of cubic nanodiamonds in the sediments and the processes that formed them. But they fail to actually spell out what they mean, and presumably they are referring to the possibility, perhaps, that nanodiamonds might be produced by wildfires, but they never actually say this in their text. And in any case, Bement's data effectively rules this out, as we'd expect many nanodiamond peaks over the last 20,000 years if nanodiamonds could be produced by wildfires. That modern peak that Bement found is really not controversial. It's interesting, sure, but it's not controversial because it could easily have been produced by another cosmic impact or volcanism, and we don't know which yet. Now, on the issue of the Greenland nanodiamonds, they say that the evidence has not been reproduced, which is correct, probably because expeditions to Greenland are expensive and need specialist knowledge. And then they say that this evidence appears to be falling out of favour. Really? Well, this is news to me. And to back up this claim, they cite the paper by Wittke from 2013, saying that the Greenland site was omitted from Figure 1, which is a list of all of the sites with the impact evidence. Now, this is a really weak argument. So let's have a look at Wittke's paper. So here it is. And this is the Figure 1 that they're referring to. This is a list of all of the Younger Dryas boundary sites that have been so far discovered. And quite correctly, they have noticed that there is a dot missing from Greenland where the nanodiamonds were found. So that is their argument for saying that the nanodiamond evidence in Greenland is falling out of favour. But that's just nonsense. I mean, the paper where those nanodiamonds in the Greenland ice were discovered is actually cited by the papers by these authors in their text. So their argument is just tittle-tattle, it's rubbish, it's noise. Basically, they have nothing interesting to say about the nanodiamond evidence. So this whole section on the nanodiamond evidence and the platinum is catastrophically flawed. So let's just recap what we found so far. Boslow completely ignored the giant comet scenario, which was previously presented to him on a plate, and can explain all the impact evidence. Then Holliday and Meltzer are very hypocritical in their arguments regarding standards of evidence for radiocarbon dating, and remember how they butchered their attempt to reproduce the age depth models of the Comet Research Group. Then the authors go on to completely misrepresent Petrovas et al.'s conclusions regarding the green and platinum data, and they've only got tittle-tattle to say about the nanodiamond evidence. And we're not even halfway through the paper yet. You get the picture. Now, we could plough on through this cosmic catastrophe paper, but you know what? When you read misleading or irrelevant arguments like this, which occur right through the paper, you begin to lose trust. This should be a debate about the science, but instead it's turned into a debate about scientific honesty and standards. And when the debate gets to that level, there's really no point continuing. It seems to me that this is more a work of propaganda than science, so I'm going to delete it. Essentially, if there's any research catastrophe here, it's this paper. Okay, that's enough for this video. We'll finish off 2014 in the next video. And if you enjoyed that, please take a look at my book and my blog.